All right, this podcast is over properties of exponents. Now, we're going to start off with some multiplication properties, but we're also going to talk about some division properties as well. So let's start with the rule product of powers. Now, algebraically, if I were to have a to the m power multiplied by a to the n power, we have like bases. A base is that a value. Okay, so their bases are the same, different exponents. The rule is add exponents. So I would do m plus n. So an example of that, I could have 5 to the 4th power, multiply it by 5 squared. I have like bases. The rule is add exponents. So I am going to add the 4 and the 2 to get 5 to the 6th power. Now if I were to use variables, same difference. Let's do x to the 3rd power times x to the 7th power. Like base of x, exponent is 3 plus 7, which is 10, x to the 10th power. Okay, the next rule is a little bit different. It's called power of a power rule. Now we have parentheses into a system. So I have a to the m to the n power. Now the rule on this is to multiply your powers. Okay, so it's kind of like the distribution factor. You're going to multiply your exponents. So for example, 2 cubed squared would be 2 to the 6th power. You multiply your 3 times your 2. Or x to the 4th power cubed, base of x, multiply 3 times 4 is 12 to the 12th power. All right, now the next rule is kind of a combination. Power of a product. Now when you have more than one thing inside the parentheses, whether it's a variable or a number, you have to distribute that to the exponent of that number or variable. So for this example, I would have a to the m times b to the m. So for example, if I had 2x squared, I would have to distribute that squared to both the 2 and the x. So I would have 2 squared times x squared. And I would want to simplify. My 2 squared is 4, so 4x squared. All right, I'm going to do another example. X cubed y squared, inside parentheses, squared. Okay, keep the same rule. You need to distribute that 2 to the exponents. So you're not actually multiplying it by the number. For example, the first example that I did, you're not multiplying by the 2. It is getting distributed to the exponent. So I have x, 3 times 2 is 6, y, 2 times 2 is 4. All right, moving on, just kind of a refresher. Negative exponents, you don't want to leave a negative exponent as your final answer. So whenever you have a negative exponent in the numerator, you move it to the denominator to make it positive. So I would have 1 over a to the m. So for example, 4 to the negative 2 power would be 1 over 4 squared, which equals 1 over 16. If you had 1 over x to the negative 2 power, so now my negative exponent is in the denominator, you take that negative exponent, put it in the numerator, so it would be x squared. There's nothing in the denominator anymore because you have moved it to the top. All right, Zero exponent rule. Anything to the 0 power is 1. Doesn't matter what it is. I could have x, y inside parentheses to the 0 power, and that equals 1. I could have 4 to the 0 power. It equals 1. All right, now moving on to the division properties. Division properties are similar. With multiplication, when we were multiplying variables with exponents, we were adding. Now, when we are dividing variables with exponents, we subtract. Now, my rule is take the small exponent to the large and subtract. Okay, it's kind of hard to visualize when we're using variables as exponents. So let's look at this. I have 4 to the 5th power over 4 cubed. Okay, they both have the same base of 4. Same base of 4. But the exponents are 5 and 3. Take the smaller exponent, so I'm taking the smaller exponent up to the top, and I am subtracting 5 minus 3. So it would be, why aren't you writing? 4 squared. Okay, another example. If I could simplify this too, sorry. X squared on top and x to the 5th in the bottom. Again, take the small to the large. Okay, so I'm taking these down to the denominator. Okay, so since I'm taking them down to the denominator, something has to replace it in the numerator. So since there's nothing there, I'm going to put a 1. So taking the 2 down, subtracting it from the 5, 5 minus 2 is 3. All right, and my last property, whenever you have a fraction inside of parentheses with an exponent on the outside. Now, the first rule is to always do parentheses. Then you need to distribute the exponent to both terms. So I would have a to the m over b to the m. Okay, one more example. Two-thirds inside parentheses squared. You can't simplify 2/3, so I am going to distribute the square to both the numerator and the denominator. 2 squared over 3 squared is 4 over 9. Okay, so that concludes the podcast for properties of exponents. Did you just toot? Okay, I'm done.